Hi everyone, welcome to the Oz Minerals and Unearthed Q&A webinar for the Copa de Cobre challenge. My name is Matt. I'm a crowd specialist at Unearthed helping to run this challenge. In terms of how today's going to work, we'll kick off, give a bit of an overview of Copa de Cobre and some introductions, and we'll follow that up with an open Q&A and a short wrap up and kind of talk about the next steps of the challenge there as well. If anyone here is unfamiliar with Zoom and the Q&A functions, you should hopefully see a little Q&A box button down the bottom. So if you open that up, you can pop your questions in there and then we'll be able to read them out and kind of answer them that way. So today I have with me Hamish Freeman and Neil Pendock from the Oz Minerals team. And I've also got Lizzie Brookman and Jan Hurst from the Unearthed team. Hamish, Neil, would you be able to introduce yourselves and tell us a little bit about what you do and how you're involved in the challenge?
Hello everyone, Hamish Freeman here. I'm employee of Oz Minerals. I am a principal geologist for project generation in the Americas. I've been doing that for about 10 years now, so I'm very involved in anything from early stage mineral exploration up to more advanced opportunities. Doing a lot of project generation work, particularly in Peru in recent times. So I've been looking after one project that Oz has in Peru. We've had other projects in the past in Mexico, in Chile. And my role is essentially to go out and find the next opportunity for the company. That's my role. Over to you, Neil.
Thanks, Hamish. Hi, everybody. I'm Neil Pendock. I'm speaking to you from Cape Town, South Africa. I've been involved in remote sensing for mineral exploration for about 30 years, all over the world, different commodities. And I'm the nasty guy who put this mosaic together of the Sentinel data. So if you've got any complaints, please direct them my way. I think it's a wonderful opportunity. And I must compliment Oz Minerals on taking a chance on this because it's definitely the way forward and the thing of the future.
I think we've got Ian Anderson in here as well, who I'm going to promote to a panelist. He's trapped as a participant at the moment. G'day, Ian.
Hi.
There you go.
Sorry for that.
No, you're right. Yeah, if you could give us just an intro of yourself and how you're involved in the challenge, that'd be awesome.
Yeah, no worries. My name's Ian Anderson. I'm in Adelaide, South Australia. I'm the Exploration, Innovation and Data Lead. And so I'm working with Hamish on his pipeline, building up an exploration pipeline in Peru. I'm looking for the next discovery.
Cool. Yeah, so if we want to, Hamish, Neil, Ian, if you want to just take us through the challenge from the Oz Minerals side and kind of what you're hoping to achieve from it, give us like a 10-minute overview. That'll be, I think it'll be a good starting point. What I'll do as well, just really quickly, is maybe share my screen so we've kind of got something to talk to as well.
Yeah, no worries. So Oz Minerals, with Unearthed, we ran the exploration challenge at Mount Woods last year. And coming off the back of that, we found that there's sort of a world of opportunity that we weren't really aware of in terms of working with the open innovation community and the crowd. And even though we were out looking for exploration targets in that exercise, we actually found a whole bunch of other things that piqued our interest as well. And so we started a innovation and data team within the company to really start to leverage all of these opportunities in working together with the crowd. And so that team basically was put together at the beginning of this year, and around the same time, Hamish came to us and said, look, I'd like to start looking more seriously at sort of unrecognized opportunity in Peru. So I want to find new belts that I can go and work in and start meeting the people working there. I want to find maybe unrecognized opportunities that we can go and get our boots on the ground and start fossicking about. So that sort of kicked us off, and I guess the situation with COVID sort of shrunk us back a little bit. So the plan of getting Hamish out and on the ground shifted, and we shifted to, well, what can we do from Australia, or what can we do from space? So without getting the boots on the ground, what can we do to start pushing sort of novel exploration? And that's where this challenge came together. And so, yeah, we put it together as a way to look at data differently, look at a bunch of free information that's come out of satellite data, and really focus our exploration efforts when the borders open up and we can get on the ground.
Great.
Hamish, you want to talk a bit about the map component?
Yeah, sure. So I guess what we're really aiming for in this competition is to discover new ways of actually looking at essentially open file information, taking that information, and is there a way that we can recognize areas from satellite data that are similar to each other? So we have metallogenic maps published for Peru and what have you, which are useful, but in this competition, we're hoping to see things or find things that are being possibly missed, and identify the next province or the next terrain, which is prospective for copper. So we're looking at identifying areas that are similar to other areas which we know are interesting. That's the primary aim. And how the contestants go about that, well, that's really up to you. Yeah. Neil, do you have any other comments?
Yeah, I think that remote sensing is a wonderful tool for geology. It's inexpensive and you can cover large areas rapidly. And you've really got two kinds of information in remote sensing. You've got spectral information. So the different rocks, soils, vegetation give you different spectral signatures. And on the basis of the spectra, you can infer what you're looking at. So you can look in the visible near infrared, you can get signals for iron minerals, which are useful in exploration. In the shortwave infrared, you can get signals about alteration, how the rocks have been deformed and changed by processes, geological processes. You can see things like clays. So that's the spectral information. And then the other information you get is spatial information, because you've got an image of the whole of Peru now, and you can see very big structures, continental scale structures, and you can see fine detail. You can see faults and lineaments, and do these spatial features correlate with the mineral deposits? So you've got a very powerful data set, and you've got two ways of looking at it, spatial and spectral. And from that, you could go the supervised route and say, okay, we know we've got a mine here. Show me the other areas that have got the same signatures, the same spectral and spatial signatures. Or you could go the unsupervised route and you could say, show me the unusual things in the data set. Because the assumption is that most of Peru is not going to be mineralized. So if we're going to find a new deposit, it's going to have something unique about it. So show me the unusual pixels in the map. They could be noise, they could be human development, it could be something of geological interest. So two ways of looking, supervised and unsupervised. And then that brings us on to the whole idea of machine learning, artificial intelligence. So we've got this giant data set, and can we mine that data set and look for targets that are going to help Oz Minerals?
Yeah, I guess I might just expand on that in terms of what Oz has been looking for in Peru in recent years. So the one project we have at the moment, Paraíso, is an iron oxide copper gold project in the coastal belt, which we've been focused on. And I guess the other type of mineralization or deposit that we've also been looking at are VMS deposits. This is in the copper space. So we haven't been focused on porphyries, but having said that, a good porphyry we wouldn't say no to as well. So I guess just the focus must be on copper.
I think importantly here, and what I think sets this apart from probably our previous work in Mount Woods, at the end of the day, we're not actually looking for only the targets. We're looking for almost like a map of the whole country. So we're looking for that difficult challenge of when you find like for like, how do you cluster that together into like one shape or a coherent shape and make that shape geologically plausible, or hopefully it is geologically plausible because it's real data and real geology. So we want sort of the whole country as a map at the end. and sort of a unique type of map. So is it going to be maybe like synthetic geology, or is it going to be all of the features, or as Neil spoke about, is it going to be these are sort of like human development, and these are natural resources, and these are the lakes, and these are the different clays, and so on. So we're looking for like a unique insight into Peru that we can use to help our exploration efforts. So at the end of the day, it's not necessarily, although it would be nice, it's not necessarily that we want targets from this. We actually want something to help focus our reconnaissance, focus our efforts in going out in the field and saying, what is this place? Why does it look so similar to the other places that we've been in this map? What makes that place unique or not unique, as the case may be? So at the end of the day, this almost isn't a targeting exercise per se. It's let's make a new tool that we can put in our toolkit and use that towards targeting and sort of recognition in the field. Oh, Matt, I think you're muted now. It's your turn.
Yep, sorry. Yeah, no, thanks heaps, Ian, Neil, Hamish. That's a really good starting point for everyone. I think provides some really good context there. So we'll open up for any questions now. So if you do have any questions at the moment, feel free to drop them in that Q&A box. And as I said, we can read them out. But just as I guess as a starting point, I've got a few here for Neil, if that's okay with you, Neil. Would you mind telling us a little bit more about the data? Kind of explain a bit more about how that spectral data recorded relates to minerals in the ground. I think you touched on it a little bit earlier.
Yeah. So the data comes from a combination of two satellites called Sentinel 2A and 2B, that were launched in 2015 and 2017, I think, by the European Space Agency. And they record 13 different spectral bands. One of them is in the ultraviolet, which is used for mapping features in water coastal zones. So we left that one out. And two of them are used to measure atmospheric parameters, water vapor in the atmosphere. So we left those out. So we end up with 10 spectral bands, which go in increasing wavelength from basically the blue-green end of the spectrum, with a wavelength of about 450 450 nanometers out to the shortwave infrared with a wavelength of about 2,200 nanometers. So it's an increasing wavelength. So you have 10 spectral bands there. So the different minerals and the different rock types and the vegetation, the different features that you can see in Peru respond differently in different parts of the electromagnetic spectrum. So for example, vegetation is green, right? It looks green. And their soil looks reddish. Why does it look reddish? Maybe because there's some iron oxides in the soil. So you can get information about what you're looking at from the spectra. So how do you extract geologically meaningful information? Well, you know, the internet is a fantastic resource. And if you type in Google, if you type in, for example, band ratio geological information, you will come across a whole bunch of information. And it's tricks that geologists and remote sensors use to extract information. So if you're looking for iron oxides, for example, if you want to map iron oxides in the whole country, rather than looking at a particular spectral band, let's say the red band, because the iron looks a bit reddish, you can look at a ratio of two bands. So the iron will be bright in the one and dark in the other. So if you do a ratio, you divide the one band by the other, the iron will be preferentially higher, okay? Because there'll be other features. For example, the cities will also be bright, but the cities will be bright in both bands. So when you do the ratio, they will drop out. So what I will do is, there are a couple of papers that are quite interesting. I'll put them on the forum so people can get more information of how to take these 10 spectral bands, which you have, and how to do simple things like band ratios to produce transformed spectral imagery, which you can then integrate into whatever else you're going to do. Maybe it's some kind of clustering. So you would like to take all of these, the reflectance data and your band ratios, and you would maybe like to find clusters. So you would like, hopefully, the vegetation to be one cluster. You would like the iron minerals to be another cluster. You You would like the clay minerals to be another cluster. But you can think about this. And as I say, the best way to start this is to get on Google and just to search and see what people are doing. And there are lots of people doing this. There are lots of websites, and you can get a lot of information for free. And if you get stuck, just to post a question on the forum, and I'll reply and I'll give you some links, because I don't want to bombard and swamp you with information. So that's the spectral. And then the spatial information is finding edges, linear features, curvilinear features, blobs in the data. And to find edges in imagery, once again, there's a lot of work being done on this, on understanding images, recognizing people in images, all this kind of machine vision. There are a lot of tools available on the internet for doing machine vision and learning, processing videos. So you can take tools from that, ideas from that as well. And in this image, which is being shown on the screen, that Matt's showing on the screen, which looks like a classified map into 7 classes, you can see what I'm talking about. You've got the different colors of the classes. You've got the greens and the olives and the reds, but you've also got the shapes. You can see some curving features. You can see some linear features. You can see things that look like rivers, etc., etc. And then there are other data sets that are available. I mean, we've given you the Sentinel, this mosaic of Sentinel 2A and 2B over the whole country, which has been stitched together to produce a mosaic. But there are other data sets that are available. NASA is recording terabytes of data every day. So there are all kinds of other data sets, which if you like, you could suck down from the cloud, and you could use that to inform your decision. For example, vegetation changes over the year, so whereas geological signals should remain constant over the year. So you can look for things that change. And we would be interested, I think, if we were looking for producing a geological map to be of use for features that don't change. So yes, indeed. But as I say, I will when we're finished here, I'll go to the forum and I'll put some ideas of how you can transform the reflectance data into a new picture, a new image band, which is going to be of geological use rather than just the straight reflectances.
Yeah, that'd be great. I think that'd be really helpful for some of the people submitting out there. One of the other questions I had was, can you kind of explain why this data is a bit sort of more challenging to work with, and sort of what you've done to make it more accessible for people?
Okay, well, the big thing is just the size of it. It's massive. It's ginormous. It's huge, and I guess we're all working on laptops. I mean, when I started out doing this in the 1980s for Anglo American, I was processing imagery in the Andes in Chile, and I was working on an HP 3000 mainframe computer, and I had 64 kilobytes of core data. So I mean, this is just a total joke, Nowadays, I mean, this little computer that I've got here now, it's got 16 gigabytes of core. So, but the image that we're dealing with is massive. It's hundreds and hundreds of gigabytes of data. So the one problem is just the volume of data. Now, the data that we've given you has a 10-meter spatial resolution. So each pixel is 10 by 10 meters on the ground. This is the highest resolution public domain satellite data available. So we're throwing you in the deep end, giving you the best stuff. We have 10 spectral bands at 10 by 10 meters. Now, if you want finer spatial resolution, you have to pay big bucks. You can buy Worldview 3 data, or you can go and join the CIA or something like that and get centimeter resolution data. But this data is 10-meter data, 10 spectral bands. So we're very keen to see what you can get out of this. As I say, this is public domain data, so it's available to everybody. There's this open skies policy, and everybody has access to this. So you don't need to be $1 billion company. You can just be an individual prospector or farmer, for example. You could be a farmer in Peru, and you could look at how your crops are doing by considering the spectral bands that respond to chlorophyll. You could see how your crops are doing. You could see how your neighbor's crops are doing. And you could say, oh, this year the maize crop is going to be down. None of my neighbors have planted maize. So let me work extra hard because there's going to be a shortage of maize in 3 months' time. So our application here is geological mapping. We want a geological map of Peru, but there are many, many other applications of remote sensing data.
Cool. Thanks, Neil. That's a really good insight there. Hamish, I think we had some questions for you as well. But as I said, if anyone does have any questions for Ian, Neil, Hamish, myself, Jan, or Lizzie, please pop them in the chat there. Hamish, could you maybe walk me through how a feature map like this benefits Oz Minerals in their exploration efforts, and how a geologist like yourself might use one of those?
Yeah, sure. So I guess I can start by saying what we've been doing in the past, or explaining how we've gone about our project generation. And we start with the published geological maps, which are pretty good, but everyone's got them. And so we're, I guess, looking for the contestants to offer something new and interesting, to find the new provinces that could be of interest with regards to copper. I mentioned that we had, in the last few years, we've been focused on things like iron oxide copper gold deposits and VMS deposits. Those belts are as well established as metallogenic terrains and that's been published. So the idea of this is to actually have a deeper look into a very large, very detailed, as Neil said, data set, and see what else is in there which has been missed, to lead us to the next area which people haven't thought about. So when we get the submissions through and we can look at the maps, ideally for us, we'd like to be in a position to say, wow, look at this. This area is similar to this area for these reasons. And when we get an opportunity, we go and look at it in the field. And that could be the start of something brand new for Peru. And obviously helps us in terms of our targeting further down the track. There are also other characteristics in the satellite data that may be of interest to us, which have, for example, vegetation and things like that, where we may be in around fragile ecosystems, and having that ability to identify things quickly put us, in a good stead when we're at an early stage of a project, when we need to know that information and how that could affect the project, or whether we should even be there. So all that type of information is of value to us as well. Yeah, so essentially it's trying to get a head start so that when we can go back into the field, we know where we want to go. And we can identify areas of ground which need to be looked at. We can identify companies that maybe already have staked ground, which we can talk to. Yeah, so that's how it should help us going forward.
Great. And so I think you may have touched on some of the geological features there a little bit, I think. Could you explain more around sort of the scale of geological features that would be useful in that final map for you to see? And
yeah, so at the moment, we're looking at polygons. If I put the polygons on the map of our terrains, which we're really interested in based on current knowledge, we're looking at hundreds of kilometres. So to take a slice of, say, for example, coastal Peru, the IOCG belt, which is hundreds of kilometres long and tens of kilometres wide, and starting off there, that's you're not really cutting down to your deposit scale. Having said that, within those big terrains, we have geological maps which have been published, and so you can see things up to 200,000, 100,000 scale geological mapping, which sort of gets you in the zone a little bit better. Ideally, with 10 by 10 data, such as has been provided, we get even better than the geological maps. In terms of scale, I mean, we're looking at project scale. So a project might be, for example, anywhere from a few kilometres across up to 10 or 20 kilometres across, that type of thing. So that's as a rough idea. Of course, within that, there may be particular areas of interest. So the whole thing is, as Neil pointed out, the whole of Peru isn't mineralised. It's much finer areas that we would be interested in actually doing reconnaissance on.
Yep. And I've got another question as well, sort of around the styles of mineralization you might expect to see and what size signatures those would have in the data. I don't know if you could expand on that at all.
Yeah. So the first thing to point out would be it depends how much transported cover is in the area. So things may or may not outcrop, or they may be covered, particularly in coastal areas. So from an iron oxide copper gold deposit perspective, you can probably have alteration up to hundreds of meters away from a mineralized system, at least tens of meters away. But we're talking about at deposit scale here now. Porphyries can be much broader, so you can have kilometre scale alteration around porphyries, and VMS can be very, very restricted in terms of their halo, if you like. They're the three that spring to mind. There are also big skarn deposits in Peru, which would be of interest to us, such as antimina, so copper zinc. And they'll have alteration halos as well associated with silicate mineralogy. It can be anything from very large, when we're talking porphyries, to something that's quite discrete when we're talking about VMS, and IOCG will be somewhere in between.
Probably something to mention, sort of to add to what Hamish is saying there, is sort of like the host rock control. And so in these big mineral systems, they're typically controlled, or they all occur within a short period of geologic time, or they'll occur in a preferential type of rock, or in a preferential structural setting, or that sort of thing. And so that's the big spatial component of this, is, and what Neil's saying is trying to like clump these things together. So if we can identify, these are the same rocks, this is the same era of deposition, or this is the same rock type, or these places underwent the same sort of like structural regime where they've been broken apart or folded together in the same sort of ways, that also carries potential. And so not necessarily being able to see the deposit, it could be buried and blind, and we might not even be able to see it from this data from a satellite, but to see the terrain and say, that's the same sort of position, or the same sort of history, the same timing, and that can draw our interest into these areas as well. And in a lot of cases, that host control, or that host rock, or that structural control, that signature is even bigger than the mineral system, and it really gets you into the sort of the right area, and you can zoom in and start focusing our effort on the ground that way.
Cool. Ian, so that question we've just had from Brian, I might just read that out, and would it be okay if I get you just to expand on that a little bit more, just for the sake of the recording there? So Brian's asked in the chat that it's stated on the forum that the use of extra data is allowed, but our code must only produce the result using the provided data set. Are we allowed to hard code values derived from external data into our programs, e.g. Spectral?
Yeah, thanks for that. Thanks, Brian. So when we were looking at this, because the Sentinel data is open to everyone and it's a global data set, we obviously would like to try and take the results from this exercise and apply the models, or the method, apply that to other geologic terrains. So maybe put it over top of our projects in Brazil, and take a look there. So we thought, look, we'd like to really just focus the results into what can you do with the Sentinel. But at the same time, we recognize that there's a lot of great other sets of information out there, and some of which Neil alluded to earlier in the call. And so we don't want to say, don't use that stuff, because we're more than confident that by using extra data sets or pulling in sort of the unexpected, well, if I use that as well, I can get a better result. We're aware that you'll come up with even better and even more exciting submissions. So we're trying to find a balance here between being able to take the results here, apply them to another terrain, but also try and get the best result out. So yeah, I think it's a tough question to put like a definitive answer on. But I think if we kept it in sort of that thinking of, can I apply this somewhere else, then that's probably the key. So in terms of like your specific question here, like, can I hard code values from somewhere else into it? Maybe an approach to say, here's where you can get these values from as a value add or something that will enhance your result. And then we can take that as part of the workflow and use it elsewhere. But if we were to hard code values in without really knowing where they come from, then it forces that to only be applicable to the area of Peru. And then we don't have a good result as like a tool in the toolkit, which I hope helps.
Yeah, I think you have to use some external data to see what you're looking at. I mean, the image is now in a geographic projection, so you can overlay it on Google Earth, and Google Earth will give you what you're looking at. It will say you're looking at the city of Lima, or you're looking at some agricultural land. So that is some external data that you're using, of course. But then there are other data sets that would be of use. For example, what does an iron spectrum look like in Sentinel data? I've got all of these millions, billions of spectra. How do I know this is a vegetation spectrum and this is an iron oxide spectrum? Well, I think what I'll do is I'll put up a link to a JPL site, which gives you spectra of all kinds of minerals and vegetation and rocks and soils. And I'll put that up so you can see what the various things look like in the spectral world. And I think what I'll also do is I'll put up the USGS, the Geological Survey of the United States, has got a database of mineral deposits all over the world. So it might be useful for you to overlay the known deposits in Peru as a way of kickstarting, a way of showing you which areas are of interest. So this, you're not actually hard coding anything. It's just another layer in Google Earth that is going to give context and help you interpret your imagery. So I'll put that up as well. And then, of course, you could go even further. There are digital terrain models. There are elevation data for the whole of the world available from satellite radar and various other data sets. So then you could imagine you could have another image of Peru, another map of Peru that would give you the height of each pixel. So from that, you could work out the slope and the aspect, et cetera, et cetera. Now that's maybe going to get a little bit beyond the scope of this competition. But all of these layers, that's the great thing about remote sensing. All of these layers are available. You've got, for example, the number of lightning strikes at any point in the Earth. Is that related to the metals in the ground? Something to think about. So that's also external data. But it's just something to think about. But I think the things that will be of use will be to a link to a JPL, Jet Propulsion Laboratory site, which tells you what spectra look like. So what vegetation looks like, what iron minerals, what clay minerals look like in Sentinel data. And then the second thing is the USGS website, which tells you where the known deposits are. So that will help you, that will give you a shortcut to seeing which parts of the image are of interest. Can you expand from the known mines to giving us an idea of where you would expect other ones to be? Or is there a spatial relationship between all these things? If you plot the known copper mines in Peru, do they all lie on a straight line? Do they all lie on a curve? Is there any spatial relationship between them?
Thanks, Neil. Just a follow-up question from Brian here. specifically calling out like the USGS Spectra data. And I think that'll be sort of like the Spectral database that they have where it says these are your sort of peaks and ratios. And if you unmix, it'll be this mineral most likely or that sort of thing. I think all of that stuff is perfectly fine to include as sort of like a reference to assist in your in producing your model. And that's the sort of thing that would certainly be applicable elsewhere. And I think when we were thinking extra data as like a scale thing, we were probably thinking like if you were to take like the global seismicity model, or if you were to take like a big seismic transect through part of the country and use that to try and take not just the near surface, but to like take your model deeper and further down, or those sorts of things that wouldn't be applicable other places. That was where we were a little bit like we'd prefer to keep it to the data set there. But yeah, if you're bringing in like a reference library that would have sort of like a global applicability, then absolutely, I think that's okay to pull that in.
Cool. Thanks, Ian. It looks like we've got another follow-up from Brian. He says, regarding the USGS deposit maps, when they are overlaid, they appear to be offset from mine locations. Would you expect to see different reflectivities at the mine than over a potential discovery, maybe due to the mining process?
This is Neil's bread and butter.
Yeah. Look, there are some geographic mistakes in the plotting of the USGS deposits. But if you have a look at them on Google Earth, you could zoom in and you can quickly see where the mine is. You can quickly see where the deposit is. So you can edit that yourself. And yeah, sure. If you started mining, you've disturbed everything now. So the virgin, the undeveloped deposit is not going to look like the open cast mine, the open pit mine, except that for example, let's say there's an iron oxide signature. You might find the iron oxide signature. You will find the iron oxide signature in the open pit, and you might find the iron oxide signature in the farmer's field that he's just plowed to plant his corn. So that would be of interest to you, because here's a spectral signature which occurs at the mine and occurs in some of the farmers' fields and not in others. Now, why is that? Is it related to geology? Probably yes. Soil has different composition. So yeah, that would be great, to have a soil map of the whole of Peru. That would be great, you would just look for the iron-rich soils.
Cool, thanks, Neil. So we'll probably wrap up questions fairly soon. So if anyone does have any other ones, as I said, just pop them in there. I do have one here as well. This is kind of to the broader team. Anyone who has a good answer for it. Can you explain why shapefiles are a preference for the submission and how geologists will use the output?
Yeah, I can jump in there quick. So I think the intent is for the shapefiles. We've probably alluded to it a few times in here that the spatial component is pretty important here. So being able to cluster things together into like for like, being able to say quickly and looking at it as a fresh map with domain attributes for Hamish to say, well, I know where I want to be in known belts. What are the attributes of those belts, and then compare and find things that are similar to those belts elsewhere. And so for like quickly getting in quick attributed data, that's the reason that we were looking for shapefiles. And we chose shapefiles as well, just because it's a fairly open format and should be something people can write to and output pretty quickly from even raster data. So we'd like to see raster data as well. If you produce both, that's great. But our key stakeholder, the person that has to finish this with a big smile on his face, is Hamish. And for him, his like raster data processing isn't as strong as his GIS and putting things into shapefiles. So we thought best thing to do is ask for something that can go directly onto Hamish's desk and he can start working with day one.
Cool. Okay, if there's no other questions from there, we might just move on to the last bit, which is kind of talking about some of the next steps and some of the other prizes we also have for this challenge. So obviously for this challenge, we have the first, second, and third prize for the teams that have the best approach to the core problem. However, we've also got two others here. One of those being the Helping Hand Award, which is kind of just so working collaboratively with everyone. If anything you can provide to help the team, also the other innovators there is a potential qualifier for that. So if you want more details on that, I would jump on the forum. The reason I'm bringing it up is the earlier you submit that, the more weight it would carry, because obviously that can help people further. And then we also have this Premier Niche Award to kind of recognize teams that kind of discover something really interesting, unusual, or niche, but might not necessarily produce outcome or solution that solves the challenge. So just to recognize that as well. I don't know if you wanted to expand on either of those at all.
Yeah, so Helping Hand, I mean, we recognize that this is a pretty huge data set and there's going to be a lot of hurdles in there. And there's also a reasonable amount of domain knowledge. And you can probably even see the gap here between Neil and myself and Hamish. Neil works in this domain extensively and he's miles ahead of the rest of us. And so the reason for that Helping Hand prize is to really encourage people. If you find a way that could probably pull a bunch of other people up to a different level and to get across some of those early domain hurdles, it'd be great to help people out and get more people into the later stages of the challenge, so you get more diversity of thought coming into the final sort of leg of it. And yeah, the sort of like the rabbit hole prize of you start working, you go down a rabbit hole, you get really into it, and you get close to the end and say like, oh man, I'm not even going to come close to solving the challenge. We think there's still value in the work that you've done there, and we're really keen to see what you come up with. So if you do find something that really grabs your attention, you get super into it and end up pursuing that more so than pursuing making this feature map, we want to reward that work and effort as well. So yeah, something crazy and unexpected coming back would be a huge success for that prize there.
Great, thanks Ian. So I guess what I'll do now is I'll just touch on some of the upcoming dates that we have. So a week from today, we'll have the early submission deadline coming up. So I'll walk through that in a minute. But about a week from there, you'll have that feedback back to you, hopefully, on your early submission. And then those final assessments will be happening just after the challenge closes on the 21st of November, which will run until approximately the 4th of December, and looking at about a 8th of December winner announcement. So for anyone kind of wondering how that early submission process is going to work, once you start your submission, you'll see this bit at the top here. As I said, until the 29th of October, so any submissions made before that point will be considered, but unfortunately anything after that can't really factor in. All you need to do is just select yes in this box here, and then just fill out this section here. Obviously anything as part of the final submission probably won't be factored into that feedback, but you are obviously more than welcome to complete your final submission early. So if anyone has any questions about that or anything else at all, please jump onto the forums. Neil, Ian, Hamish, Richard, who's also one of the judges, myself, pretty much everyone on the team is able to answer questions there where it's relevant to them, of course. And if you have any questions about any of the other Unearthed challenges, obviously, please let us know as well. The challenge is open for about another 3 weeks, I believe, is about right. Oh, sorry, 4 weeks. Open for another 4 weeks. So you've got heaps of time to make your submissions and get the word out to any of your friends who might be interested as well. This recording will be uploaded to, I believe it'll be YouTube, and we posted on the challenge page here as well. So if you jumped in late or if you just wanted to revisit it, it will be up on YouTube in the page here. As I said, if anyone has any questions, please feel free to reach out via Slack or the forums or email or anything like that. Did anyone on the panel have any final comments that they wanted to add? No,
I just wanted to say thanks to everyone that came out for the webinar today, and thanks to everyone that's taking part in the competition. I'm really keen to see what comes back. So thank you.
Yeah, absolutely. Big thank you to everyone who's attended and everyone who's submitting. Really looking forward to the what comes through at the end. And with that, I think if we don't have any other final questions, we'll wrap up. Cool. Thanks everyone. Ian, Neil, Hamish, thank you for coming. Much appreciated for your time to answer those questions there and provide the additional context for the challenge. It's good speaking to you again.
Oh, thank you, Matt. It was a
Cool.
pleasure, and thanks for hosting.